Welcome to a lesson with Dr. Powell. Let's take a look at an integration, double integration, where the region isn't a nice rectangle or square or something where we're finding the volume underneath a surface that's over a particular region in the XY plane. Perhaps, for instance, this region looks something like this. Y is equal to 4 minus x squared. Maybe we have something like a line coming up like this, right? And suppose this is the x-axis. And this line right here can be given by y is equal to 2 minus x. And suppose, for instance, that our surface is given by the equation f of xy is equal to x times y. All right. So how would we do this? Well, let's call this region R. So then we're looking at a double integral. Sometimes we just use this notation R here before we specify exactly what's happening with the iterated integrals. And we just write down loosely a dx dy to signify we're kind of thinking of little pieces like d of area. We're taking dx times dy. So basically we're integrating with respect to x and y, and that's what this means here. And then we put down our function xy. So this is kind of notation for what we're going to be looking for, the volume under this curve. Now, keep in mind in general, volume can be positive or negative, just like the area under a curve we think of as positive area versus negative area here as we're integrating, whether it's above here the x-axis or below the x-axis, we'll hear above or below the xy plane for volumes. But it's the same kind of idea. We won't really be needing that for this example, but I just mentioned it anyway here as we think about our integration. So for starters, how are we going to do this? Integrate over this region. Well, we first pick a coordinate, x or y, so that it's easy to specify sections of this region with in terms of that coordinate as that coordinate goes between specific values. For instance, like x goes between 0 and 2, very specific values here from 0 to 2 in this region, right? And that covers this region. Now, as x goes from 0 to 2, what's happening with y? Notice that y changes what it's going from, but that depends on x. So the bounds at a particular x value depend on that x value for y. That means as we construct this integral, we first think 0 to 2 for x, and then we're going to have an integral here in terms of y. And in this integral, we're going to have bounds that depend on x, which is okay because this inner portion should be a function of x, and it will be if these bounds are functions of x. So the bounds, let's see, what is the y value here in terms of x? Well, we use this equation because it tells you how this x coordinate is related to this y coordinate via this equation. In fact, the y coordinate is 2 minus x, so that would be like the lower bound for y. The upper bound would be right here, 4 minus x squared. And then we put in our surface function xy, and we have just constructed our integral that we're going to compute. So let's go for it and see what kind of progress we can make on the computation of that integral. Okay. So first we start with the inner integral. We just kind of iterate through them. So remember in this inner integral, y is the variable, x is serving like a constant in there. So we have, we take the integral of x times y with respect to y, where x is like a constant, so we'd end up getting xy squared over 2. And we evaluate it at these different points, 2 minus x and 4 minus x squared, and take the difference. And we're going to get an expression in x when we do that. And that's what we're going to be integrating over the interval from 0 to 2. So this will help us know the volume that's underneath the surface xy. That's over this region when we do this. Okay, so we plug in 4 minus x squared into this. And you know what? We can even, okay, so x over 2 can just sit on the outside here. It's like a constant with respect to y here. We could just kind of put it out, like factor it out, and just take the difference of y squared, basically. So plug 4 minus x squared into y squared. So we get 4 minus x squared squared. Subtract off 2 minus x plugged into y squared. So we get 2 minus x quantity squared. Okay, so this is what what it looks like right now at the moment. I'm just basically plugging this in here and subtracting off what this is plugged in, but I just realized that x over 2 occurred in both, and I just kind of factored it out. That's basically what was happening. Okay, so I expand this. So I get 16 minus 8x squared plus x to the 4th. Here we get minus 4 plus 4x minus x squared after multiplying and distributing the negative. Okay, all that is multiplied to x over 2. All right. So we can keep the 1/2 factored out, say, just keep the 1/2 out here. And just multiply the x through. So we end up getting, and maybe we should combine terms a little bit. 16 and negative 4 combined to a 12. And let's see, then we have a plus 4x. And then we get a minus x squared and minus 8x squared, so minus 9x squared. Plus x to the 4th. Okay, but then we're distributing the x through. So we end up getting 12. So we end up getting 12x plus 4x squared minus 9x cubed plus x to the 5th. We have not integrated that portion quite yet. Okay, so now we integrate. Okay, and so we end up getting, so let's keep the 1/2 on the outside here. I'll just write it right here. And we end up getting 6x squared plus 4/3 x cubed. We're going to get minus 9/4. That's 4 here, x to the 4th. And we have plus x to the 5th. Let's just kind of write that right there. Okay, so we have 0. So plus x to the 5th over 5. Okay, and we take this and we're going from 0 to 2. And computing that. And in doing that, we end up getting, okay, but we made one little mistake here on integration. That would be x to the 6. Yeah, that's x to the 6 over 6. All right. And we're going from 0 to 2. And so then we plug in 2 into all of these and compute, and 0, and then take the difference. And we end up getting 14/3 as our result. Thanks for watching.